Welcome. I'm Ramo Murakami Gutierrez, Senior Product Manager of the Spatial and Graph capabilities in the Oracle AI Database. Data is more connected and complex than ever, and understanding those connections is key to innovation and smarter decisions. In this video, we'll explore the challenges of relationship-driven data and how Oracle AI Database Graph lets you model, analyze, and unlock deeper insights in your existing information. Let's dive in and see how Graph and AI are shaping the future of data analytics. Everything is connected in today's world, and your data is connected in many ways. Those connections might look like customers connected through a social network. They could be bank accounts connected by how money flows between them. When you're able to model and actually understand those connections in your data, you can start asking much more interesting questions. For example, what are the 3 degrees of separation between entities? Can I find all people within 3 hops of a specific customer? Or let's say you have a fraudulent bank account. You can ask, find me all accounts that are directly or indirectly connected to a specific account through money transfers. These types of questions are extremely difficult to answer using traditional row and column structures. But when you model your data as entities and the relationships between them, when you explicitly capture how things are connected, those same patterns become much easier to identify. And that's really what graphs are about, making relationships first-class citizens in your data model. Graphs apply across a wide range of use cases. You see them on financial services for identifying fraud rings, in recommendation systems where products, users, and behaviors are connected, in supply chain analysis where dependencies and upstream risks matter, and in many other domains where relationships drive insight. So what is a graph? Instead of rows and columns, a graph model is made up of entities and relationships. For example, you might have an entity like Oracle, a company connected to other entities such as events it organizes, products it offers, or customers it serves. Graphs make it easier to represent information that's either unusual, ununiform, or highly interconnected. Things that don't fit neatly into rigid schemas. There are 2 common types of graphs. The first one is the property graph. This is a very flexible model for representing and analyzing relationships where both entities and connections can have properties. The second is the RDF graph, which is based on standards and is particularly useful for representing meaning and enabling interface, deriving new knowledge from existing relationships. Both models are supported. And when you're using Oracle AI Database, graph is a native feature. Just like you have tables, you also have graphs directly inside the database. That means you can work with relational data, JSON data, and graph data together. You don't have to move your data into a separate, specialized system just to work with graphs. The same data stored in tables can be accessed as a graph. You can create a graph view on top of existing relational data using standard SQL syntax. The data is stored once, but viewed in multiple ways, as tables, as views, or as a graph. This is part of the SQL Property Graph standard, which defines how you create and query graphs using SQL. And it's fully implemented in Oracle AI Database. Once you've created a graph from your existing data, what can you do with it? You can start identifying patterns. For example, you can detect suspicious structures that indicate fraud rings. You can find multiple paths between entities, like understanding how 2 fraudulent accounts are connected through intermediaries. You can identify highly connected entities based on connection patterns, for example, customers with similar buying behaviors. Or you can analyze how information flows through a network, which is especially useful when studying risk, influence, or misinformation spread. Another major use case for graphs is knowledge graphs, which are particularly relevant in the AI era. When you do vector-based text search, the results are probabilistic. You're matching chunks of text based on similar scores. Graph search is different. Graph allows you to connect entities across those text segments. Instead of looking at pieces of text in isolation, you're using relationships to retain context and meaning. For example, keywords or concepts that can be represented as nodes in a graph and their relationships help refine search results. This is where ontologies come in. An ontology is a type of knowledge graph that captures domain-specific knowledge curated by experts. For instance, in biomedical research, experts build ontologies that describe how proteins are related to each other. So if you ask a question like, find all interactions between a specific protein and a disease, you can combine similarity search over research papers with known relationships stored in an ontology. The result is much more accurate and relevant than using similarity alone. So once you have a graph, how do you interact with it? You have several options. You can use natural language, which gets translated into a graph query and executed in a database. If you prefer writing code, you can write graph queries directly in SQL using the SQL Property Graphs syntax. You can also use Python or Java APIs, especially useful if you're running graph algorithms like community detection or machine learning approaches such as deep work. These algorithms help you find patterns and relationships that aren't obvious at first glance. You can run queries and algorithms using standard SQL tools, VS Code extension, or Jupyter notebooks, and visualize the results along the way. To summarize the key value of graphs in Oracle AI databases, you can unify graph data with relational, JSON, spatial, and other data types, all in one database on one scalable platform. You get high performance, security, auditing, and availability without copying data elsewhere. For advanced analytics, graph algorithms run on a specialized in-memory graph engine designed for recursive, traversal, and high-speed execution. You also get built-in tools like Graph Studio available whenever you provision an autonomous database. Both property graphs and RDF graphs are supported, and everything integrates with AI, including vector search, RAG, and large language models. To close with a real example, Industrial Scientific, a global leader in gas detection for workplace safety, had customers and product data spread across multiple databases. Because of data inconsistencies, customers' names and addresses didn't always match. This led to missed orders, lost invoices, revenue loss, and customer frustration. They use graph technologies to integrate data across systems, identify which customers were actually the same, and detect missing invoices and overdue payments. They improved governance and workflows at less than 5% of the cost of traditional data governance tools. Here are 3 ways to get started. First, Oracle AI Autonomous Database Free is fully managed, so you don't have to worry about infrastructure. You just build, and it's production grade even in the free tier. Second, FastLab and LiveLabs. If you want to learn quickly, start with a FastLab. If you want to go deeper, LiveLabs walk you through real use cases, from the basics to the more advanced scenarios, and you can try all of it for free. Third, build a GenAI application. Use Python to build things like RAG, vector search, and agent workflows on Oracle AI Database and OCI GenAI, and walk away with code you can actually reuse. My recommendation, run a FastLab, pick one use case, and start experimenting this week. Build something small, test it, and see how graphs change the way you query and analyze your data. Thanks for joining us in this journey into connected data, graph analytics, and AI-powered transformation with Oracle AI Database. Whether you're new to graph technology or ready to take your application to the next level, now is the time to explore, experiment, and unlock the insights hidden in your data. Don't forget, start with FastLab, try a sample project, and see how easy it is to integrate graphs with your current workflow. Discover what's possible when you connect your data and your ideas with Oracle AI Database. Thanks for watching.